Hello, good evening, student. Am I audible? Am I audible to you? Okay, and my screen is also visible. Is my screen is visible or not? I think my screen is visible. Okay, good. Okay, so we should start now. Okay, I have shared my slides. So if slides are not visible, then uh, please tell me. So I will do something. Okay. So today we will discuss about week 4. Okay. First of all, we will discuss important point of week 4. Then I will discuss about the assignment question of last semester, which will help you to solve question answer of assignment number 4. Okay. So I think it is 705. So persons are just a minute. Okay, so we should start now. Okay, so in this week, in first lecture, sir discussed about the overall formation constant. Okay, it is overall formation constant. Okay, so how to understand about the overall concept? Suppose we will discuss about any. Suppose it is metal. Suppose it is metal complex. Okay, and it is react with another ligand like that. Okay, and it will give Ml5 X plus N. Okay, so this is the we can say it is a first reaction, and the reaction constant for this first reaction is K1. Second, Ml5 X, when it will again react with X, it will give Ml4 X2 plus L, then it will be K2. Okay, similarly this will again react like Ml4 X2 again react with X, and it will give Ml4 X3 plus. Okay, so it will be continue. Okay, this reaction will be continue. Finally, what will you get as a product? Means sorry, it is Ml3. Okay, yeah. So finally, what will you get? Means all L will be replaced by X. Okay, so finally you will get Mx6. Okay, and it will be finally K6. Okay, So when you will calculate overall reaction constant or overall formation constant, okay, beta, so it will be equal to multiplication or product of all these reaction constant. Okay, so it will be multiplication or product of the this all reaction constant. Okay, so we can say it is a step reaction. Okay, and in step reaction, just a minute. I think some persons are waiting on. Okay. Student, please try to join on time. Okay. Okay. So this is all about formation constant. Okay. Then sir discuss about the buffer solution. Okay, it is very important for analytical chemistry. Buffer buffer solution, or what is buffer, and all things we will discuss. Okay, so buffer means it will resist to change pH. Okay, means it will suppose your it will try to keep pH constant. Okay, it means it is not mean that it will suppose your pH is 5.5, if your solution pH is 5.5, so it will keep exact 5.5. No, it is not like that. Some variation will be there. Okay, plus minus 0.1 or plus minus 0.2. It can be it will depend on particular buffer, but it will try to keep it constant, but it is not exact constant. Okay, some variation, some tolerance will be there. Okay, so or we can say it will be the pH range will be constant for particular reaction. Okay, so for that we use buffer. Okay, so it resists change in pH when it is diluted or when acid or base are added. Okay, where in two cases, what are the two cases? First, when it is diluted, okay, and in second case when acid or base are added in your solution. Okay, so and why we are discussing buffer solution here? Because it is very important in your titration. Okay, so in titration, whenever you are doing titration, the pH range should be constant. Okay, because no, pH range should be constant at end point. Okay, so at end point only if pH will be constant, then only your indicator will give color and you will identify that which product is there. Okay, so for that it is very necessary. Then what we are discussing about, so yes, sorry, slides are not visible to you. Means I am saying, yeah, now it is visible. Is it visible to you? No? Okay, just a minute. Is it okay now? Is it okay? Are you able to? Are you? Okay, good. Okay, good. Okay, so let me check. Is there any waiting room? Okay, so are you able to see what I am writing here? Are you able to see? No? Okay, just a minute. Okay. So next we will discuss about the Henderson and Hasselbalch equation, which will help to calculate. Just a minute. Why it is not able to? Okay, which will able to calculate pH when pK value is given. pK value plus concentration of your concentration of Na means sodium salt of acid divided by concentration of HA. Okay, means concentration of acid and concentration of acid. So example is of this you can understand: CONA and CH3COOH. Okay, so this is, it will be reflecting this and this will be reflecting this. Okay, so by this way you can calculate the pH value of the given solution. Okay, now how pH is work? Yes, again why it is so? Just a minute. Okay, when I'm annotating, you are not able to read it. Am I right? Okay, yes, just a minute. Now is it visible? I'm annotating something. So are you able to see? Hello? You are still not able to see. Just. I think now it is visible. Are you able to see now? Hello? Yeah, okay, okay, good. Now I think we are able to. Okay, so we have discussed about this equation. Then how means this buffer solution work? Okay, so suppose I will discuss here one example of buffer solution. Okay, suppose it is uh, CS3 CO sodium acetate plus its weak acid, so it is a CS3 COOH. Okay, so this suppose this is one example of buffer. Okay, so when it will be dissociate, it will give you CH3 CO minus plus Na ion. Then second it will give CH3 CO acetate plus hydrogen. Okay, so what will happen, how it will manage pH? Okay, so how it will, suppose you are adding acid. Okay, suppose you are adding acid means you are adding a hydrogen ion. Okay, so what will happen, this hydrogen ion will be react with this acetate ion. Okay, negative ion, and the this equilibrium will shift toward this side, means left hand side. Okay, and similarly when you add OH minus ion, okay, then what will happen, then it will react with positive ion. Okay, and your equilibrium shift toward right hand side. Okay, but overall it will be balanced. Okay, overall so equilibrium will be adjusted and the pH will be remain same. Okay, so this is the working principle, or you can say working mechanism of buffer solution. Okay, so then yeah, these both problems are solved by only CH3COH acetic acid. Then why we are adding CH3CONA here? Because when it will be consumed, okay, CH3CO minus ion will be consumed. Okay, then this reaction will be shift in the right hand side. Okay, so the shortage of acetate ion will be fulfilled by this sodium acetate, by this acetate ion coming from sodium acetate. Okay, so overall this reaction will be balanced and your solution pH range will be remain constant. Okay, so this is the working mechanism or working principle of buffer. I think it is clear. If any doubt you can ask. Okay. So how many are there? Okay, so this is one thing. So this is first time I am using this. Oh, good. Okay, then yes, how it will buffer will help you to maintain pH. Okay, so we will understand by one graph here. Okay, suppose this is the pH. Okay, and when you are adding HCl, suppose drop wise you are adding HCl, okay, on x-axis, so what will be happen? Okay, obviously when you are adding HCl, So concentration will decrease. Okay, concentration concentration of solution will be decreased. Okay, like yes, it will be decreased like that. Okay, so it can be more precisely we can say. Okay, just a minute. Suppose your concentration will be here. Okay, so it will be decreased. Okay, but when you will use buffer, okay, so your pH will remain constant. Okay, so it will help you to analyze in analytical chemistry, which will be discussed further. Okay, so this is the basic principle. Okay. Then another thing is, what is buffer capacity? Okay, another thing, what is buffer capacity? Okay, so suppose you have one conical flask, and in this conical flask you have 1 liter of solution. Okay, 1 liter of solution. Okay, which solution? Buffer solution. Okay, solution which is a buffer solution. Okay, so its pH will be pH range will be constant. Okay, so how you can change the pH range by either by dilution or by adding acid or base. Okay, so how much acid you need, how much strong acid? Okay, it should be strong. Okay, how much strong acid you have to add? Okay, so your pH will not change. Okay, till pH will not change, how much strong acid will be added. So how much means what? Okay, how we will measure acid or base? So we will measure in mole. Okay, so how much mole of strong acid or strong base we will add? Okay, till pH of this solution will not change. It will be considered as buffer capacity. Okay, so if your buffer is good, then it can handle more the pH will not change if you are adding more acid and base. Okay, I think one person in waiting room, so let me. Okay, okay, then let me clear frame. Yeah, buffer capacity is clear, I think. Okay, then yes, we will discuss one more buffer solution. Okay, which is naturally occur. Okay, and it will minimize the effect of air pollution. Okay, and it is caused acid rain. Okay, so we know that mainly SOx means sulfur oxides and NOx. Okay, these two gases are responsible for acid rain. Okay, so when these gases will be contaminate your air, okay, then it will make some acids. Okay, like H2SO3, H2SO4, like okay, acids like NOx also make HNO3, HNO2, like that. Many types of oxo acids of nitrogen and sulfur will be formed. Okay, due to these gases. This gas, when this acid will be produced, okay, it will be it will be come down with rain, and it will decrease the pH of water. Okay, so nature has one protecting system, okay, where this pH can be managed. Okay, so for this purpose, the buffer solution is made of CaCO3, H2CO3, or HCO3 minus. Okay, so this buffer will be present in system. Okay, and it will help to maintain pH of your system, okay, constant. So it will very helpful for aquatic life and for crop and all other things. Okay, so this is about the naturally occurring buffer. Okay, then we will move toward titration. Okay, titration is volumetric estimation. Okay, and equilibrium process and pH constant. Okay, so what will be happen? This example we will discuss later. Okay, so if we will draw one graph. Okay, suppose this is the pH and this is the suppose it is acid concentration. Okay, so what is happening here? Okay, suppose from here, okay, so means from here to here pH is decreasing drastically. Similarly from here to here pH is changing. Okay, and this is the plateau. Okay, this is the first and this is the second plateau. Okay, so why this type of curve obtained? Okay, so suppose this is the so pH is decreasing here. Okay, so pH is decreasing means acid is forming. Okay, obviously. Suppose it's carbon dioxide. Okay, and if you are adding acid, so what will happen? Suppose you are adding HCl. Okay, so what will happen? This carbonate, just a minute, CO3, it is CO3 only. Okay, so what will happen? It will make HCO3 minus. Okay, and it is also reversible reaction. Okay, so when you will add HCl initially, HCO3 minus ion will be produced. Okay, so initially it will be this is because it is a reversible reaction, so equilibrium will be established, but you will add more HCl. Okay, then all the CO2 concentration will be converted in HCO3, and its pH will be decreased suddenly here to here. Okay, after that here this HCO3 minus again react with HCl and it will produce H2CO3. Okay, so this reaction will be occur in this area, and finally when all HCO3 will convert in H2CO3, the pH will again decrease suddenly. Okay, like that, and at the end this will be due to leveling effect of water. Okay, so this is all about how reaction will be happen. Okay, mole of KOH. Okay, so I am going to by this thing. Okay, okay, leveling effect we have already discussed. Leveling effect is caused by water. Okay, because water can give both H plus and OH ion and OH minus ion. Somebody getting me? Okay. Then we will discuss about the salicylic acid. Okay, so the structure of salicylates. Okay, here I will discuss 2 to 3 points which are very important for you. Okay, so pKa value for this hydrogen ion, you can see this hydrogen ion, OH. Okay, so pK value for this is 13.40. Okay, it will give hydrogen ion. Similarly, pK value for this is 2.9, suppose 2.9 something. Okay, so this, okay, so by this way, how what we can interpret, okay, means pK value is higher here 13.40 and here it is only 2.9. Okay, but this is the strong. Okay, means this group is strong, strongly give hydrogen ion compared to this. Okay, so by this example we can conclude that if pK value is higher, then your acid will be weak. Okay, so like that you can compare in future also. Okay, why it is so? Okay, you can also calculate. So what is pK? pK is nothing but logarithm of K. Okay, so now suppose we will discuss about two examples. Okay, so you have two Ka value. So Ka1 is 10 power minus 4 and Ka2 is 10 power minus 2. Okay, so from here we can say which K is higher. So this K is higher obviously. Okay, but when you calculate pK value from this K value, Ka1 and Ka2, if you calculate pK value, then what will the value? Just a minute, let me erase it. Okay, so pK1, suppose first of all I will calculate pK1. So it will be minus log of 10 power minus 4. Okay, and I think you know about that. This minus 4 will come at front of log, so it will be minus, will be multiply minus, it will be plus log 10, 4 log 10. Okay, and log 10 value is 1, so pK value will be 4. Okay, however, by same process, if you will calculate pK value 2, it will be 2. Okay, you can do it in your notebook. Okay, so see, now pK value is 4 and here pK value is 2, but which one is strong? pK value 2 is strong. Okay, so never confuse with this thing. Okay, always pK value is inversely proportional to Ka value. So if pK value is higher, then your acid will be weak. Okay, if pK value is higher, your acid will be weaker. Okay, similarly for base also, if pKb value is higher, then your base will be weaker. Okay, then yes, so this thing is also important. Okay, pH measurement, we are talking about the pH measurement. Okay, pH measurement is also very important. Okay, in organic matter, when organic matter fermented, okay, what is the fermentation? Okay, fermentation is nothing but chemical change of organic material. Okay, chemical change of organic material. Okay, in digestion by microorganism. Okay, so it will call as fermentation. Okay, so suppose when organic matter will be fermented. Okay, and it will produce SCO3 minus plus fatty acid. Okay, so due to development of this species, the pH will be decreased. Okay, So it should be known to us which how much pH is decreasing. Okay, so we can design our reactor, or the reaction of this organic matter can be occur efficiently. Okay, so this, okay, now we will discuss how this pH change is important in our analytical chemistry. Okay, okay, first of all we will discuss about spectrometer. Okay. Spectroscopy you can say. Okay, so what is the meaning of spectroscopy? Means spectroscopy. Okay, generally it is taken means that we are dealing with some radiation. Okay, so spectroscopy include all electromagnetic radiation. Okay, IR, visible, UV, all these things. Okay, so measurement based on light and other form of electromagnetic radiation. Okay, what is spectroscopy? So spectroscopy is measurement based on light and other form of electromagnetic radiation. Okay, so suppose you have any sample in this beaker. Okay, and if light is passing from this sample, okay, so two phenomena can be occur. What are these two phenomena? It can be either absorbed, so light can be absorbed. Okay, light can be absorbed or emitted. Okay, so light can be absorbed or emitted means how it will be emitted. Absorb you can understand. Okay, so first it will be absorbed and then it will be emitted. Okay, so you can measure either absorbed light or emitted light. Okay, to measure that which compound, which element, which molecule is present in your sample. Okay, by that way you can understand. Okay, so for that you can use a different type of spectrometer like UV spectrometer, visible spectrometer, IR or infrared spectrometer. Okay, so how this work? Okay, I told you that if sample is there in your solution, it will absorb light. Okay, but how it will be occur on atomic level? Okay, so we will discuss like that. Okay, first of all I will draw atom. Okay, this is the very basic structure of atom. Okay, so suppose there is one electron. This is the electron. Okay, just a minute. Okay, so this is the electron. Okay, when suppose light is falling on this electron. Okay, so this electron can jump on a higher step. Okay, from here to here. Okay, so what happen when light fall on electron? The electron absorb the light. Okay, light is what? Light is form of energy. E is equal to h nu, na? Okay, so energy of this wavelength is suppose E. Okay, so when this energy, or we can say light, will fall on this electron will be excited and jump on higher step. Okay, so this is called as absorption. Okay, it is called as absorption of light. Okay, we can say absorption. Okay, absorption of light is there. Okay, but at higher state it is not quite stable. Okay, because this is the rule of universe, that each and everyone want to live in lower energy state. Okay, each and everyone want to state in lower energy state. Okay, suppose you are doing suppose we are doing some work. Okay, but after doing some work we need to again means again want to relax for some time. Okay, means this is over ground state. Okay, so similarly when electron is excited in a high state, it will be again jump in ground state, and here it will emit the energy. Okay, or we can say emission. Okay, so it will be absorption of light, and it is emission of light. Okay, so it will be occur at atomic level. Okay, and it will also occur at molecule level. Okay, when some atom will make bond and form molecule, then it will be also. So we will also discuss about how it will be applicable to molecule. Okay, then just a minute. Okay. So suppose now I can tell one thing. Yes, suppose. Okay, for better understanding, we can say this is the ground state and it is excited state. Okay, this is the electron. It is jumping here to here. Okay, and again here to here. Okay, so we understand this thing. Okay, now it will here it will absorb energy, and here it will emit energy. Okay, and the difference between these two state. Okay, suppose this state has E1 energy and this state has E2 energy. Okay, so difference between these two energy state is delta E, and it will be E2 minus E1. Okay, so this atom will be okay, now we are discussing about only a single atom. Okay, so this atom will be absorb or emit a particular energy radiation. Okay, because this energy gap is identical for particular element. Okay, or particular atom, so it will emit only particular wavelength, and according to this wavelength you can identify that which elements you are dealing with. Okay, so like that you can characterize or you can analyze any element present in your sample. Okay, similarly we can say that yes, one example is given here. Okay. So sir explain one example which I want to discuss here also. Okay. Suppose you have suppose in our indicator, okay, suppose it is methyl red. Okay, it has this chromophore. Okay, azo group. Okay, due to presence of double bond, it will be act as a chromophore. Okay, because it will give a particular color which will be help to identify your end point. Okay, so how it will be help? Okay, similarly when nitrogen and nitrogen, okay, here if we there are two bond. Okay, it is double bonded. Okay, so one is sigma bond and another is pi bond. Okay, if you are not know what is sigma and pi bond, then I will tell you the sigma bond will, when two orbital will overlap head to head like that. Okay, suppose this is the first atom, this is second atom. If they will overlap head to head, then it will make sigma bond, whereas if these two orbital when overlap by side, then it will make pi bond. Okay, this is only refreshment of your concept. Okay, so this is the sigma and pi bond. Okay, which are making bond here. Okay, now just okay, so if we will make molecular orbital diagram, okay, so first of all if we make sigma bond, so it is sigma bond, okay, sigma bond, then it is pi bond, okay, and here we can see that nitrogen has one lone pair also, okay, lone pair means two electrons which are inert, okay, here, so it will be n also, okay, so and then it will be pi star anti-bonding, okay, and finally it will be sigma star anti-bonding of sigma bond and anti-bonding of pi, okay. So when electron will jump from here to here, n to pi, sorry, n to pi star, or electron will jump from pi to pi star, so these two transitions are very important, okay. Why it is important? Because when electron will jump from here to here, it will absorb the energy which is fall in visible range, okay, so it will be in visible range, so we will identify, we can identify, okay, okay, so this is uh, means the particular compound will give particular wavelength, okay, or particular color of light, so you can identify by this way, okay. So here I want to discuss one more concept which is very important, okay, just a minute. So suppose I am assigning this transition as a 1 and this transition as a 2, okay. So in first transition electron is jumping from n to pi star, okay. In second transition electron is jumping from pi to pi star, okay. So obviously when electron jump from pi to pi star, it required more energy, okay, it required more energy compared to first transition, okay. So it can be interpreted that when higher energy will be required, okay, it will give means if higher energy required for this transition, okay, it will give particular color, okay. So why I am talking like that? Because if you know about the 7 color, okay, these are the 7 color: violet, indigo, blue, green, yellow, orange and red, okay. So when it will absorb more light, okay, so means what to happen, it required more energy, okay, so it can absorb only violet, okay. Why it can absorb only violet color? Because it has low wavelength or high frequency, okay. So it can we can assign that for second transition we require suppose violet color of light, then the first transition will require red color of light, okay, because it required very less energy, okay. Then we are using some terms here, wavelength and frequency. So what is this, okay? Let me clear from. Okay. So electromagnetic ray, you all know that it is like that. Okay. Wavelength means if you are taking this distance, okay, from here to here, it is known as a lambda wavelength, okay. And frequency means you can say in 1 second, okay, 1 second how much lambda will be passed from this slit, okay. So this is the slit and this electromagnetic rays is passing from it, but how much lambda will be passed from this slit, which is known as frequency, okay. So we can say E is equal to H nu, okay, or H nu is equal to C upon lambda. Okay, so this is all about the wavelength. What is the wavelength? Okay, so if frequency is higher, okay, or we can by this relationship what we can say, energy is proportional to inversely proportional to lambda, okay, or frequency is also inversely proportional to lambda, okay, or we can say frequency is also inversely proportional to lambda, okay. So if your radiation has higher energy, okay, then it will be has very short lambda like that. Okay, so here lambda is high but frequency will be low. Here lambda is low but frequency will be high. Okay, and if frequency will be high, energy will be also high. And here frequency is low, so energy is also low. Okay, so this is about common very basic concept about electromagnetic radiation and how it will be absorbed and like that. Okay, so it will be very helpful for your next classes. Now we are going to discuss about ferric, how we analyze ferric ion, okay, by calorimetry. So suppose it is Fe3, okay. When it will react with thiocyanate SCN minus, it will make complex of Fe SCN. Okay. So it has one charge, okay, and it has three charge, plus 3 and minus 1. So it will be overall charge of this molecule will plus 2. Okay. So and why we are making only why we are selecting only this ligand, because it will give red color, okay, red color of specific wavelength, okay, which can be identified by our spectrometer, and we can say that yes, SCN is present, okay. And this is, you can say, qualitative analysis. By identifying this lambda, you can say yes, FeSCN is there, so obviously iron is there. Then by measuring the intensity of P, okay, how much intensity is there, okay, it will be proportional to quantitative analysis, means how much iron is there, okay. So there are two things. First, you will qualitatively know that iron is there. Then by intensity of this peak, you can say means how much iron is present, okay. So this question. Okay, so in laboratory we are using indicator. Okay, so what are the indicators? These are generally weak acid. Okay, and what happen when this indicator will dissociate? It will also give hydrogen ion plus remaining indicator. Okay, ion means remaining indicator, and it will give it will also give you Ka value, okay, which can be concentration of product. So which are the product? H plus and In minus divided by HIN. Okay, so by this way we can calculate pK also, okay, and by pK can be calculated by minus log of K, okay, and by pH value can be calculated, okay, and pH are generally pK plus minus 1, okay. So if we know about the what say pK value, we can estimate that how much pH will be there, okay, where this indicator will change, okay. So for it is given here for phenyl sulfone Thelin, okay, it is 6.8 to 8.4. Okay, 6.8 to 8.4. Okay, so at 6.8 it will give different color, yellow color. Okay, and 8.4 it will give red color. Okay, so you need to measure. Okay, suppose your pH is changing. Again I will make a step up. Okay, suppose it is changing here, 8 to 9. So here you can use this indicator which will give color at 8.4. Okay, at pH 8.4 it will give color. Okay, and you can use very you can identify 8 point very easily. Okay, effectively. Okay, so suppose it is suppose it is 7 and it is 6. Okay, so suppose this is also can be identified. Okay, if your pH because pH is changing 6.8. Okay, so suppose it is yellow color, here it is yellow color, so yellow color too it will change. Okay, in middle we cannot say about exact, but when pH will reach till 8.4, it will again give you red color. Okay, so by this way you can identify your titration. Okay, endpoint of titration. Okay, similarly bromo, this is bromicresol. Okay, it will also give yellow and green color on different pH. Okay, this all things about that. Color solution. Similarly for aluminum also we are using. Similarly for aluminum, okay, if we are going to titrate aluminum, first of all you need to convert it in Al+3. Okay, you can do it by either by aquaresia, okay, or by NaOH, or okay, so we can say aquaresia AR, or by using base like NaOH. Okay, you can dissolve aluminum, then it will make Ml, means complex with ligand. Okay, so ligand is 8-hydroxyphenolene. Double bond. Here it will be N, and here it will be H. Okay, so it will make okay, it will make complex with aluminum. Okay, how it will make? So suppose it is N here. Then we make just a minute. There is space here, so it is not detected. Okay, or we can draw here only. Suppose this is the aluminum. Okay, so these two coordination of aluminum will be satisfied by one ligand. Okay, so this hydrogen will be removed. Okay, like that. Okay, similarly another Okay, similarly another two molecule can be attached, and yeah, uh, it will make aluminium L3. Okay, means 3 ligand will be there. And overall this molecule will be neutral. Okay, because uh, one molecule of 8 hydroxy quinoline will provide one negative ion. Okay, so total 3 ligands are provide 3 ligands will provide total 3 ions, 3 negative ions, and overall this will be neutral. Okay, or in Al L3, or we can write it with like AlOH3. Okay. Then finally, similar to this, we discuss about two ligand. Okay, uh, to identify iron, okay, there are two type of reagent. One, 10, phenolphthalein, and okay. So these two what we can say indicator. Okay, these two indicator will give red color. Okay, but it will give at different wavelength. Okay, 510 and 562. Okay, so according to that your spectrometer will read this reading, okay, this wavelength, and will give that iron is present, okay, in the particular indicator. Okay, but suppose you are using dithiazine. Suppose you are using dithiazine. Okay, so it will give pink color. Okay, in presence of lead and zinc also. Okay, so if lead is present, then then also it will give pink color, and if zinc is present, then also it will give pink color. So if both are present, then you cannot identify that which element are present. Okay, so these are the some limitations are also there. Okay, for this indicator, so we have to select indicator wisely. Okay, so it can solve our purpose. Okay, so this is all about this week lectures. Okay, I just discussed many important points which will be help you to understand the basic things. Okay, any question? Otherwise, now I will solve the assignment question. Okay, so it will help you. Are you able to see my screen again? If my slides are not visible, please tell me. Okay. Okay, so here how do buffer work? Okay, this is already explained, but I will go fast here. like it is CH3CONA, Na, okay. You can say sodium acetate, okay. It will dissociate in acetate ion and sodium ion. Similarly, if it is okay, this is the mixture of buffer, okay. It will give hydrogen ion and acetate ion. So how it will manage, okay, and how it will resist to change pH when acid is added, okay. First case, when acid is added, okay. So the amount of H plus ion increase. These are quickly removed by reaction with ethanoate ion, okay. So it will be, so the acid will react with this ion, okay, and it will make acid. So the overall equilibrium will shift toward left hand side, okay, and shift to the left. Second case, when alkali is added, okay, alkali means when you are adding OH minus, okay. So this OH minus will react with this hydrogen ion, okay, and it will make water, but the equilibrium will shift in this right hand side. Why equilibrium shift in right hand side? Because it will fulfill the decreasing concentration of hydrogen ion, okay, because hydrogen is sorry, because hydrogen ion is consuming by OH ion, okay, hydrogen ion is consuming by OH ion. So to fulfill this shortage, the reaction will be proceed toward right hand side, okay. So this is the working principle of this thing, okay. Then it is also discussed, but it will very clearly you can understand what is the wavelength, okay. So these are two peaks, okay. So distance between two peaks, okay. It is amplitude, okay, from the middle of electromagnetic radiation, okay. Then you can understand that what is the, okay, it is starting from higher frequency to lower frequency, okay. So higher frequency, okay, if you move in this direction, okay, in toward higher frequency, it will be UV light, and if you will move toward lower frequency, then it will be IR light, okay. So this this spectrum is visible spectrum only, okay. This spectrum reflected visible. So if you see the violet color, it is 400 to 420 nanometer, okay. So what is the meaning of nanometer? Nanometer means 10 raised to power minus 9 meter, okay. So you can imagine how short wavelength is this, okay. But when you move from violet to red, okay, it is 620 to 780 nanometer, okay. Means what is happening here? The wavelength is increasing, okay. Suppose violet is like that, then red will be like that, okay. Means wavelength will be higher for red compared to violet, okay. So for this purpose I add this slide, so you can understand. Just a minute. Who is waiting there? Only first slide is visible. Just a minute. Okay, good. Okay, so this is the second slide, okay. So there are two cases, okay. Suppose light is falling from this bulb, okay, visible light is falling, okay. So your sample will absorb particular means wavelength, okay, and it will emit particular wavelength, okay. So means suppose it is absorbing red, so it will not absorb, it will not emit red, okay. If it is okay, so how we will understand? So that which color will be absorbed and which color will be emitted, okay. So for that we can say it is Week-4 only, okay. Suppose it is Week-4, okay, and if you are making circle like that, then the light absorbed, okay, and light emitted will be just opposite. Generally it is opposite, okay. It is not means thumb rule, but you can make an idea, okay. If violet is absorbing then yellow will be emitted. Like that you can get some idea of that. Okay. Similarly, if blue is absorbing, then orange will be reflect. Okay. So by this way you can make an idea which light will be absorbed, then which light will be emitted. Okay. So are you able to see assignment number 4 here? First question. Are you able to see assignment number 4? Okay. Okay, good. Okay. So these questions are taken from last semester. Okay. And it will help to solve your assignment of this current semester, and it will also, we will also discuss some concept. Okay. Meanwhile, solving this question. Okay. So question number first. Which instrument is used for acid-base titration? Okay, it is acid-base titration. Okay, so acid-base titration, what will happen? Okay, suppose you have acid. Okay, and you want to measure acid. Okay, and you are taking burette from the you are taking base from the burette. Okay, so what will happen after some time? Neutralization reaction will be there. Okay, neutralization means base will neutralize acid, and at the end point both acid and base will be react fully, and it will be neutralized. Okay, so which thing we can use here? Okay, which thing we can use? Any idea? Colorimetry, pH meter, or potentiometer, or all of the above? Obviously, what will be changed? pH will change, na? No? Okay, so pH is right answer. Okay, so for acid base titration, the pH metry instrument is used. Okay, pH because initially it is only acid. Okay, so pH will be lower. Okay, less than 7. Okay, and when you are adding base, so pH will be rise. Okay, so pH meter will be used for this purpose. Okay, pH meter is electric device. Okay, used in measurement of hydrogen ion activity. Okay, so pH meter is nothing but it will use it is a means glass electrode. Okay, it is like that, and it will measure the activity of hydrogen ion in solution. Okay, so hydrogen ion activity, either it is acidic or alkaline. Okay, in solution, fundamentally a pH meter consists of a voltmeter attached to pH responsive electrode. Okay, so a one voltmeter will be attached. No, don't worry to understand about that. And a reference on reactive electrode. Okay, so it will be like that, voltmeter, and one electrode is there which is unvarying. Okay, unvarying means inner electrode. A colorimetry can measure the absorbency of light. Okay, colorimetry means what? We discussed, na, like in iron, in aluminum, what is happening? Means it is absorbing some light and emitting another light. Okay, so by absorbing of the light, you can identify that which element is there. Okay, so this is the principle of colorimetry. Colorimetry can measure the absorbency of light where during color measurement the change in the intensity of electromagnetic radiation in the visible wavelength region of the spectrum after transmitting or reflecting by an object or solution is measured. Okay, so from the solution it will be transmitted or by reflecting. Both way are possible. Okay, transmitting means it is passing from the solution, and reflecting means it is reflecting by the solution. Okay. A potentiometer is an instrument for measuring voltage or potential difference by comparison of unknown voltage with known reference voltage. Okay, so means some reaction is going on. Okay, some reaction is going on your sample. Okay, so it will change. If it is change potential, okay, then also uh, it will give some indication, okay, due to change of potential, and it can be used for measurement of unknown species. Okay, so these are all about this question number B. Okay, so question number 2. Question number 2 is, in wastewater treatment, what is the byproduct if anaerobic treatment process are used? Okay, so what is the wastewater treatment? First of all, wastewater means it contains some organic matter. Okay, so when it will be digest by anaerobic means in absence of oxygen. Okay, or only limited oxygen will be there. Okay, and after some time the oxygen will be sought. Okay, because the continuous reaction will be going on. So after, because there is no source of oxygen. Okay, so it is called as anaerobic. So what will happen? Some bacteria are there. Okay, who is getting on? Okay, whatever. Yes. Slide not change. Question number 2 is not visible. Okay. Okay, now I think it is some technical. I will share one answer. Okay, so what will happen? Organic matter, okay, in anaerobic condition, some bacteria will okay, with help of some enzymes, they will convert this in some useful product. Okay, so what are the useful product? So here you will get biogas. Okay, here you will get biogas. Okay, so biogas is nothing but mixture of methane and CO2 and some other propane and butane, like that. Okay, so this gas also can be used for fuel. Okay, so biogas is right answer, I think. Yeah, biogas can be a byproduct if sorry, anaerobic treatment processes are used. Okay, just biogas can be a byproduct if anaerobic treatment processes are used in wastewater treatment. Biogas is partially methane and carbon dioxide. Biogas is produced by anaerobic digestion with anaerobic organisms. Okay, it are generally bacteria which digest material inside a closed system. Okay, closed system means what? Oxygen is source of oxygen is not there, it is closed. Okay, or fermentation I have already explained. Okay, fermentation is what is meaning of fermentation is chemical change of organic matter, okay, with the help of enzyme. I am repeating, chemical change of organic compound or organic matter with the help of enzyme. Okay, so which digests material inside a closed system or fermentation of biodegradable material. Okay, what is the meaning of biodegradable? Means where living organism like bacteria or whatever, okay, can digest this thing. Okay, so it is biodegradable. Like cellulose is biodegradable, but plastic is not biodegradable because plastic cannot be digested by the commonly found bacteria and other things. Okay, so this closed system is called an anaerobic digester, biodigester, or bioreactor. Okay, so these are the different names: bioreactor, biodigester, okay, or anaerobic digester. So I think second question is clear. My slide is changing now. I am now in question number 3. Okay, so let me check if somebody texts. Not visible, slide not changed now. Okay, I think question 3 is visible to you. Okay, good. Okay, so question 3, identify the correct statement for the medicine aspirin from the following statement. We have already discussed the structure of salicylic acid, okay, which is used for aspirin. Okay, so it acts as a acid, weak acid. It acts as a strong base. It acts as a buffer. It is a neutral. Okay, so we have already discussed it is act as a buffer. Okay, how it will be? It will be given in the answer. I think it is there. Okay, so this is the structure of aspirin. Okay, this is the acetic acid group. Okay, in general we can write COH. Okay, so this group is COH, and it is a, you can say what it is a COR group. Okay. So how it can be how it can be behave as a what say buffer, because it can give hydrogen ion. Okay, it can give hydrogen ion. It can also absorb basic like hydroxyl ion. How it can be okay, because it will give hydrogen ion, so this hydrogen ion can be react with OH. Okay, similarly, if hydrogen ion is coming, means acid is coming from outside, it can give electron from the lone pair. Okay, oxygen has 2 lone pair, no? So it can give electron like that. So it can behave as a buffer. Okay, so aspirin is a common drugs for relieving minor ache, pain, and fever. People also use it as a anti-inflammatory or blood thinner. Aspirin also known as acetyl salicylic acid. Okay, act as a buffer to maintain pH. Widely used worldwide as a anti-inflammatory and antibiotic. Okay, these are common information about the aspirin, but our main goal, how it will behave as a buffer. Okay, then question number 4, a suitable indicator should experience a change in color of the reaction. Okay, a suitable indicator. What is suitable indicator? Should experience change in color. So when it should give color. I think just a minute. I think again the slide is not changed. Question 3 is visible now. I think question 4 should be visible now. Is it there? Are you able to see question number 4? Okay. I think question 4 is visible. If not, then please tell me. Okay, good. So what is question number 4? So suitable indicator means we discussed na like that. Suppose this is the pH range. It is changing from here to here. Okay. So suppose if in this region, okay. Suppose this is the pH scale, and this is your volume of what say reagent, okay, which you are adding. So if pH here, if in this pH range, if your indicator is changing color, okay, then it is very good. Then we can tell that it is a suitable indicator. Okay, so where the color should be changed at the end point. Okay, so this is the end point, means here the reaction is completing. Okay, so we can say it is end. So close to the equivalent point, acidic region, basic region, either acidic or basic region. Okay, so close to the equivalent point. Okay, so close to the equivalent point should be right answer. Okay, so answer is a suitable indicator should be chosen, preferably one that will experience a change in color at end point or close to the equivalent point. Okay, either it should be end point or close to the equivalent point of the reaction. When a weak acid react with a weak base, the equivalent point solution will be basic. Okay, when a weak acid react with a weak base, the equivalent point solution will be basic if the base is stronger and acid is stronger. Okay, so what this statement is saying, that when a weak acid react with weak base, the equivalent point should be basic. Okay, so obviously when weak base is you are adding, so end point will be basic. Okay, and if the base is stronger and acid and acidic, if the acid is stronger. Okay, so if acid is stronger, then obviously this is nothing, means makes sense. Okay, then question number 5 is question number 5. Consider the following statement regarding the buffer. Okay, again we need to check that which statements are right for buffer. Okay, so in a buffer solution, on addition of small amount of strong acid or base, pH increase sharply. Okay, so this is not right. Okay, so this is the means purpose of buffer. If you are adding small amount of strong acid or base, the pH range will be not changed. Okay, so this is the work of buffer. Okay, so the first statement is wrong. B statement is the principal buffer or natural buffer is mixture of bicarbonate ion and carbonic ion. No, it is also not correct. Okay, the principal buffer is natural water. Okay, so sorry, it is natural water. Yeah. So the principal buffer of natural water is mixture of bicarbonate ion and carbonic ion. Yes, it's a mixture of, we discussed now, CaCO3 and H2CO3 and HCO3. Okay, so this is the buffer solution. So bicarbonate means H2CO3 and carbonic acid. Okay, so this is the right answer. This is our right statement. Then statement C. For a solution of a strong acid and base, the Henderson-Hasselbalch equation is pH is equal to pK plus log base upon acid. Okay, so it is strong acid and base. Okay, so strong acid and base, so obviously it will be, so what is strong acid and base, so it will be, base will be as a product side and it will be acid. So this is right. Okay, so our right answer will be D. Okay, because B and C statement are correct. Okay, so question 5 is clear. Any doubt till here you can write me. Okay, so this is the explanation of this question. Question number 5. In a buffer solution, on addition of small amount of strong acid or base, pH remain nearly constant. That's why your first sentence was wrong. So the answer A is wrong. The principal buffer of natural water is mixing of bicarbonate ion and carbonic ion. Okay, good. For a solution of strong acid and base, the Henderson equation is this. This is right. Okay, so finally, answer 3 is correct. Okay. Now question number 6. Which of the following are acid base indicators? I think it is not visible. Okay. So which of the following is followings are acid base indicator? Okay. So phenolphthalein is very common, and we have taken example of phenolphthalein many times. So you are sure about that. Okay, phenolphthalein we are using. Okay, but there are some another example like thymol blue, Congo red is also used. Okay, alizarin is used, yellow, alizarin yellow. This is also used for acid base. Methyl red, cyclopropyl, this is not right. Then methyl red, protein chromat is also not right. Methyl blue, okay. So yeah, so the answer A is correct. Okay, it is only this question answer only can be given on the basis of experience, okay, or on the basis of your expertise in analytic chemistry. Okay, so don't worry about that. There is no concept, okay, which can be discussed here. So you can memorize this type of things. Okay, methylene blue, potassium dichromate are redox indicator. Okay, so these two are redox indicator. Okay, so if these are in your option, then option will be wrong. Then erichrome black tea is used for complexometric titration. Okay, complexometric means what? Where complex is made. Okay, means when you are using EDTA. Okay, so EDTA will make complex with your ion. Okay, metal ion. Okay, so I can understand. I can give you some insights about how it will make complex with EDTA. Okay. Here one carbon will be there, so let me add it. Okay, here also it will be. Okay, so this is the structure of I would say EDTA. Okay, so here it can give means I think I have done some mistake. No, it is sorry, it is not right. Okay, it will be this is the right structure. Is to see right. Okay, so you can these things you can do. Okay, so here how many dented means how from how many sides it can capture metal. Okay, so these are the two nitrogen and there are 4 oxygen. Okay, 1, 2, 3 and 4. Okay, OH2. So this one ligand can attack metal, okay, from 6 sides. Okay, so this will make a complex with this metal. Okay, so this type of reaction are known as complexometry titration. Okay, means what will happen? Okay, so this metal will be surrounded by, okay, nitrogen. So it will give like nitrogen like, okay, it will make bond like that, coordination bond. Okay, then it will be CH2CO. So it is, this H will be removed and it will make bond like that. Okay, so similarly another also nitrogen, then one another group will be there, CO, O minus, it will be also make bond like that. Here also nitrogen, so same thing here also. Okay, so 2 bond will be made like, okay. So this EDTA molecule will surround this metal ion totally and it will make complex. Okay, so it is known as complexometry. Okay, so where we have complexometry titration. Okay, complexometry titration means ligand is making complex with metal ion. Okay, like that. Okay, so phenolphthalein, thymol blue, Congo red, elazine red, methyl red are acid based indicator. Okay, so you can memorize these indicators. This shows color change with change of pH. Okay, at particular pH. Okay, so it will be depend on your reaction. Okay, so what is the change of pH of your reaction or your titration? So according to the pH change, you need to select your indicator. Question number 7. 7 is which of the following conductometric titration will show a linear increase of the conductance with volume of titrant added up to break point and almost constant for conducting afterward. Okay, so I am reading question again. Okay, it is a little bit tricky question. Which of the following conductometric titration, okay, conductometric titration will show a linear increase, okay, of the conductance with volume of titrant? Okay, means if you are adding titrant, then the conductance remain constant. Okay, then only it will show linear behavior. Okay, so means it will be like that. Okay, added up to break point and an almost constant conductance afterward also. Okay, so it will be not in the case of strong acid and strong base, because in strong acid and strong base conductance will be changed. Strong acid and weak base is also not possible. Weak acid and strong base is also not possible. Weak acid and weak base, yeah. So this will be the right answer. Okay, how it is that I will explain you in this question. Yeah, here you can see a graph and you can explain here. First of all, it is strong acid and strong base. Okay, and volume of acid added. Okay, so what is happening here, that at particular volume the pH of solution will be decreased sharply here. Okay, because you are adding strong acid. Okay, and base is also strong. Second, in the second case, it is strong acid and weak base. Okay, so it is a strong acid, so volume of acid you are adding. Okay, so here you can say, okay, so decreasing the pH is not sharp. Okay, but it is decreasing, so it is not sharp line. Okay, it is not straight line, linear, it is not linear curve. Then weak acid and strong base, so it will also give you end point, okay, but not sharp like that when you add acid. Okay, pH will be changed, but it is not sharp color. But if it is weak acid and if you are adding weak base, okay, so it will be so the pH is changing very minutely and it is almost linear. Okay, so that's why the option D is correct, means it is weak acid and weak base. So this is the explanation for the plot of weak acid and weak base. There is no steep beat on this graph. Okay, steep beat remaining all graph you can see that there is a steep beat. Instead there is just what a known point of inflection, that leg of the steep beat, that it is difficult to titration for weak acid and weak base. Okay, that's why you are not getting any end point like that. Okay, so you cannot titrate weak acid with weak base. Okay, so it will be not give you reliable result. Okay, so this is the limitations of this titration. Okay. Then question number 8, which function group is responsible for color change in methyl red indicator? Okay, in methyl red indicator, which color methyl red? Okay, so I think it is diazo. Okay, because diazo is already it is known as a chromophore. It is known as a chromophore, and chromophore is responsible for color change. Okay, why it is so? I have already told you that there are two transactions is there. First is n to pi star and second is pi to pi star. Okay, this transition will give color and it will be help to identify. Okay, what is given here? Let me read. Methyl red 2N and dimethyl 1,4 aminophenyl azo-benzyl oxalates, also called as indica. They turn red in acidic solution. Okay, it is a azodie and in a dark red crystalline powder. Methyl red is a pH indicator. It is a red in pH under 4.4, yellow in pH 6.2. Okay, so what is the range of this? Is 6.2. Okay, so if it is higher than 6.2, it will give yellow color. Okay, and at pH 4.4, it will give red color. Okay, and orange in between. Okay, so from here to here, it will give orange. Okay, with pK of 5.5. Methyl red has been considered carcinogenic potential in human. The diazo part, okay, diazo means this one, diazo. This group is known as diazo. It has one lone pair also like that. Okay, each nitrogen has one lone pair. So this is diazo for this color. Okay, so I think this option is not correct. Okay, it is given A, but it is not A. Okay, it should be C. Okay, so the answer of this question is given wrong. Sorry. Okay, then question number 9. Question number 9 is, what is the pH range of color change in phenyl sulfone phthalate and which form is observed toward red cell? Okay, so this structure is already discussed. Okay, and this pH range is also discussed. Okay, so it will be, what is the pH range of color change of phenol sulfone phthalate and which form is observed toward red shift? Okay, so second question is, which form is observed toward red shift? Okay, so when color is changed red, then uh, 8.4 suppose color is changed. Okay, so which species will be there? Okay, so it will be discussed. So this reaction is like that. Okay, initially this is the yellow color, but when H is added, when acid is added, okay, so it will be give like that. Okay, so OH minus will react with this H ion, okay, and it will give water. Okay, then this oxygen will be negative, it will be react like that here. Okay, so double bond will be formed. Okay, and this all things will be adjusted, and finally this bond will be broke, and finally this will be great. Okay, so this is a little bit more typical chemistry. Okay, so you need to understand this thing. It is only memory based, you can say. Okay, a solution of a solution of phenol sulfoxylene is used as a pH indicator, often in cell culture. Okay, in cell culture, it is biology, cell culture. Its color exhibit a gradual transition from yellow, okay, to red over the pH 6.8 to 8.2. Okay, so 6.8 it will be give yellow, and at 8.2 it will give red. Above pH 8.2, phenol sulfoxylene turn red. In medicine, phenol is used as a test to help diagnose problem or disease of the kidney. Okay, so these are the general information about this compound. Okay, then question number 10: which reagent is used for the quantitative analysis of aluminum? Okay, this is already discussed. Okay, so it is a 8-hydroxyquinoline. Okay, then how it will make more? Okay, so here you can see this is the aluminum. Okay, it is +3. Initially it was +3, no? And this is the 8-hydroxyquinone. Okay, but when one hydrogen will be removed from here, okay, it will give negative ion. Okay, so total 3 negative ion, first, second, sorry, we can write here first, second, and third. So 3 negative ion will be given by these 3 oxygen atom, and finally it will be neutralized. Okay, so this overall this complex is neutral. Okay, overall this complex is neutral. There is no charge. Okay, so aluminum is determined by precipitation it with 8-hydroxyquinoline in a ammoniacal solution. Okay, so why you are using ammoniacal solution? Any idea? Aluminum is determined by precipitation with 8-hydroxyquinoline, and here also we discuss about only reaction about aluminum plus 8-hydroxyquinoline. Okay, but in this statement it is also written that ammoniacal solution. Ammoniacal solution means ammonia. You are adding ammonia, or you can say ammonium hydroxide. If ammonia will be dissolved in water, okay, ammonia dissolved in water, it will make ammonium hydroxide. Okay, okay, so it will give ammonium hydroxide. So let me write clearly ammonium hydroxide. Okay. So why we are adding ammonium hydroxide is there, because we need to remove this hydrogen ion. Okay, and how this hydrogen will be removed? Okay, so suppose it is ammoniacal solution. Okay, suppose ammonia is there. Okay, so ammonia can take. Okay, so ammonia has the nitrogen has one lone pair of electron. Okay, so the hydrogen ion will be attracted by this lone pair. Okay, so it will be converted negative ion. That's why we are using ammoniacal solution. Okay, this ammonium hydroxide will again give ammonia, and this ammonia will remove hydrogen ion from 8-hydroxyquinoline. Finally, this negative ion will react with aluminum, and it will make complex. Okay, and finally you can write this as a aluminum L3 or aluminum or X3, okay, which already discussed. Okay, this is all about this week. Okay, I think I have clear all this thing. Okay, question, I think this was the question. If you are not able to see, I am unable to see the structure. Okay, not able to follow this. Why? Just a minute. What happened? Many messages. Question 3 is visible now. Now able to follow you. Now not able to follow you. Can't see what you are. I have to see the structure. Slide not trained now. Not visible. I think it is some technical issue. Okay, so I will try to resolve. Okay, so this is the end of this session. If you have any doubt, any question regarding the lecture discussed by sir or in the current session, you can ask. Only few slides. Okay, so these slides will be shared in the folder. Okay, so you can download from there also. Okay, and this whole video also will be uploaded. Okay, so you will get the link of this video and you can go through it again. Okay, okay, so we will meet in next week. Okay, till then, bye bye. If you have any question, you can ask, otherwise we will meet in next week. Okay. We have 2 to 3 minutes. If you have any question, you can write in chat box. Okay, then I am going to stop the meeting. We will meet in next week.
Ugh.